let's go. 2015, day 20. Infinite elves and infinite houses. To keep the elves busy, Santa has them deliver some presents by hand door to door. He sends them down a street with infinite houses numbered sequentially, 1, 2, 3, 4, 5, and so on. Each elf is assigned a number and delivers presents to houses based on that number. Okay. Let's just... So first elf goes 1, 2, 3, 4, 5. Second elf goes 2, 4, 6, 8, 10. Third elf goes 3, 6, 9, 12, 15, and so on. All right, so... Okay, there are infinitely many elves. Each elf delivers presents equal to 10 times his or her number at each house. So the first 9 houses on the street end up like this. So this is just factors, right? House 1 got 10 presents. Well, if we ignore the 1 at the end, or the 0 at the end, it says 1, 3, 4, 7, 6, 12, 8, 15, 13. So it's basically the sum of the factors of the number, right? Right. The factors of 2 is 2 and 1, so we get 3. Factors of 3 are 3 and 1, so we get 4. Factors of 4 are 4, 2, and 1, so we get 7. Factors of 5, right, this prime. Factors of 6 are 6, 3, 2, and 1. So 6 plus 3 is 9, plus 2 is 11, plus 1 is 12. All right. So that's all that is. What do we have to figure out? What is the lowest house number of the house to get at least as many presents as the number in your puzzle input? And my puzzle input is this number. Okay, this seems fairly straightforward. It may just be slow to calculate because you can see the numbers don't monotonically increase, so you can't like do a binary search for them. Houses with a lot of factors are going to have a lot of gifts compared to houses with few factors or prime numbers. Right? A prime number house is always going to get its house number plus 1 times 10 presents. But I guess that would put an upper limit on where we have to search from, and maybe we just search from backwards from that. Like, what's the largest prime of 34? What is this? 3.4 million, right? I'm taking off the last 0, and then we could just search backwards from that. But then finding primes is going to be okay. Well, let's see. Let's just dive in without thinking about it. Our usual workflow is to just create a new day like that, and then we just add this day 20. Airdog, thank you for the follow. Welcome to the channel. Okay, so we have this. We tried to build, and the build fails because we don't have this file. And let's do this. We do this. AOC 2015 day 20. All right, and then we should have a unsolved over here. If we do run, there we go. Okay, so we're all set, ready to go. How do we figure this out? I guess one thing we could do is, well, we have this target number. We could just save that, right? We don't need to create an input file for that. We can just say like const, I don't know, what should we make these? U64s. Target equals this. And then I could do the slow way and then see if there's a faster way to do it. How to calculate the largest prime less than this value, and then work our way backwards from there. Well, let's try working our way forwards and see. It's going to be whatever the square root of this is. I don't know. Let's see how slow it is to go starting from the beginning. And then calculate. Oh, so how do we calculate all the factors of? I mean, the other option would be just to create an array and then put all the elves, all the presents in the array, and then just search the array. And we could just keep going until we hit this number. I don't know if that would be slower. And then it's the lowest house number of the house to get at least this many presents. All right. Well, I mean, I'm trying to think of a way to do this. This seems like it would be super straightforward, but it is. My brain is getting stuck on this. Let's create an array here, or vec of houses. U64, let's say. It shouldn't need a U64, but we'll do that anyway. So then this is houses vec new. And then parse function doesn't do anything because we don't need to do anything. Actually, the parse function could set up the array, right? For, I don't know, elf in 1 to some number. What's the square root of this, maybe? Let square root is equal to, oh, can you calculate a square root on an integer in Rust? Rust integer square root. Oh, I guess you do this. Unreliable results? Why? Often one errors for larger than 2 to the 53. That's true, but we're not going to go that high. Okay, so square root is going to be target as f64 dot square root as u64. Okay, and then 1 to square root. Oh, I guess we have to fill it, right? We could say houses, self houses. And we learned this in one of the other streams about being able to extend vectors. Rust extend vector with number. There's a way to extend it. Resize with. Each additional slot was filled with the result of calling the closure f. Is there a way to do, I guess the closure can just be a number, right? Resize with 0. Will that build? It doesn't complain. Oh, it does have an error here. Oh, that's right. We have an issue here. Every so often, Rust Analyzer will, I mean, the compiler quick fix list won't work. Cargo clear. Clean. Yeah, so maybe resize with is not. Oh, resize takes a value like that. Okay. And then this rebuilt. This didn't rebuild. I can do test and let it rebuild that way. Cargo, no, nvim. There we go. So we just do resize. Yeah, now it's rebuilding it, so it's going to take a little bit longer. Oh, resize still takes 2 arguments? New len. Right. Squirt. With 0. There we go. Expected use size. There we go. Now we got a warning. That's fine. So for each house now, we say house, self houses of elf Oh, no, no. Each elf now visits each house. Right. So we're going to say for visited in elf through to square root. Step by elf. Then self house is visited plus equals elf times 10. Right? They're delivering 10 presents. Oh. Maybe I should do all of these as U size. That way I don't have to do this business here. But then I have to say elf as U64 times 10. All right. That's fine. And now part 1 is just search. Let's print out the last one, println, just to see if we got as far as we needed to go. Let's go to run over here, and then we can say println, and this would be self houses last unwrap. So we didn't go as far as we need to go, right? Oh, that's not that. So we're looking for the house. That's how many presents were delivered to this house. So we don't want to go to square root of target. I thought that would be it, but we can do, let's do 1,000,000. And just to see how far that gets us, and then maybe we can figure out, and let's call it limit. Okay, so that got us closer, right? It's probably more than we need, right? Because that's higher than our. Oh, that's not higher than our target, is it? No, our target is. Let's put these in here so we can actually see. It's 34 million, and this is only 20 million. All right, let's double it. Here, limit. We should be able to actually just stop it here, right? If we hit a house that has enough, we should be able to stop it there. Oh, and doubling it to 2 million only goes to 21 million. We still have to get to 34 million. That's weird. Let's go to 4 here. This vector is going to be huge. And it takes a while to run because of this. Oh, well. Okay, but it got us there, right? We're now at 57 million. Okay, so what I can do here is just check, right? Once we hit a house that has the target, is that our lowest house? If self houses visited is greater than or equal to target, then we can just put found here. And then found 0. You can just say found equals visited, and then break outer. Right? And then we can print self houses. We don't want that, so we want found. Found equals found, and then value equals this. And we can see if that's the right answer, right? Self found, self houses, self found. Oops, self found equals visited. Still takes a little while to run. All right. So this was the first house that had this value. I don't know. But that allowed us to stop, right? I don't think that's the right answer, because other houses might have, if we keep pushing the limit here, other houses might have more. But this will give us a limit at least. And then we can stop at that limit, right? So we can say let mute if found, if this is greater than target and visited is less than limit, then we can just say limit equals visited. And then here we just search for the first one that has more than the target. I don't know. Let's see. For I in, or for house in self houses. If house is greater, oh, house is going to be a star. Yeah, ampersand. So if star house is greater than or equal to target, then we're going to say println, oh, return crate output house. Otherwise we're going to print out on can't find a good home. All right. Yeah, it's slow. I mean, it took 10 seconds the last time. I was hoping that this would clamp it. Oh, that's the value. I want the number of the house, right? IDX house in self houses iter enumerate. Yeah, it took 10 seconds though. That's disappointing. Disappointingly slow. And I put that in the parsing phase. All right, so let's see. We have a number. I have no idea if we're even close to being right. And if this doesn't work, then what we'll do is just do the brute force thing I did last time. Oh, that is the right answer. All right. I wish it weren't so slow though. Cargo, run, release. Okay, so in release mode, it takes about a little over half a second. And in debug mode, it's 10 seconds. Wonder why. Is it all this range checking? No, it can't be that, right? Because we do that in release mode as well. Maybe it's going up to this limit. Oh, and now we're not setting found anywhere, right? What we can do is print this, save it, right? And then print it out at the end. Self found equals visited. Println limit is self found. Oh no, I'm anxious to get to part 2, but I just wanted to see this. Oh yeah, now we don't need outer either. Oh, that's interesting. We don't need to get to 4 million if, I mean, 1 million should be sufficient. Let's see if we can do that. And if it goes a little faster. Yeah, so now it's only 2.2 seconds for debug mode, which, okay, I can live with that. And it still comes up with the right answer. Figuring this out, though, what's the square root of 34 million? So that didn't work, whatever that was. It's only 5,000. Yeah. All right. Those can go away. Okay, so this works. We set it for 1 million. We try to do it. We get there in the end. We search for the house. And we print it. So, and it's always printing out the last one, which is interesting. Bacon. So that's interesting to know. All right. Git status. Git add source. Git commit. 2015. Day 20. Part 1. Oh, we're not using limited now, right? Oh, wait. Attempt to mutate a range bound within a loop. Oh. Oh. Yeah, I mean, I'm not actually trying to, but what if I did a break here? Would then Clippy not complain about it? Because I would not be trying to change the range bound at that point. And that's the same answer, I believe. Oh, no. Well, let's continue to part 2 and then we'll see if that, yeah, 76,240. Yeah. So that's the same answer. But I think we're going to have the same complaint here, right? Oh, no. Oh, I didn't save it. Oh, yeah. So putting the break there means that we don't have to worry about it. Okay. Very good. And we got it down to 2.39 in debug mode. So that was part 1. Part 1 still takes 33 milliseconds to run through all the numbers. So part 2 is, the elves decide they don't want to visit an infinite number of houses. Instead, each elf will stop after delivering presents to 50 houses. To make up for it, they decide to deliver presents equal to 11 times their number at each house. With these changes, what is the new lowest house number of the house to get at least as many presents? Okay. So that means we're going to refactor all this away again. So this will go like this. This now becomes part of the main loop, or the part 1 loop, because there's no reason to have it global. I thought we'd be able to use that house information for part 2, but I am wrong. So we'll just say mod houses equals spec new. Oh, you could just say vec bang limit 0 u64 limit, and then just put limit here. And then we do this, and it's no longer self houses, it's just houses, and then we just do that. So this should still work. Not quite. Oh, because we don't need this anymore. Yeah. 76,240. Okay, so good. So now we have to do the same thing, but 11 times. And we stop after 50. Okay, so it's almost exactly the same code. So let's do that, and then we'll just edit it to, yeah. So instead of 10 times, we do 11 times. That's the first change. And the other change is we stop after 50 houses visited. So let 50 is equal to the limit dot min of elf times 50. Right, because if elf is 1 and our limit is 1,000,000, then elf times 50 will be 50. But if our elf is like elf 1,000 and our limit is, I don't know, 5,000, then elf times 50 will be 50,000, and this will be 5,000, so we'll stop after that. So I think that's it. Elf to 50. I spell right. And step by elf. And then we do the same exact thing here, and then we could just stop after that and then print out the output once we hit the target. All right, let's see if that's close to being good. It went a lot faster. Why did it go so much faster? All right, we have a different answer. Oh, it went faster because we stopped after 50 elves. Yeah, okay. So is that right? It is. Huzzah! All right. Day 20 was super easy once I wrapped my brain around the problem. 2015, day 20, part 2. All right, well, that means we can keep going.